In this video, you're trying to find a relation between focal length, image distance, and the object distance. Now, first thing what we'll do is we'll do the same thing for a concave mirror. Okay, now for a concave mirror, so consider this to be the concave mirror. Okay, then first thing is you need to do one principal axis. So imagine this is the principal axis. Now remember, here we need to draw an object, correct? So this is the principal axis. Now what we are doing is we are considering an object on the principal axis. All right. So consider some object here. So this is the object. So imagine this is the object. Let's call this as A, call this as B. Now AB is the object. Now from AB, a ray of light is coming. Okay, now since we are talking about concave mirrors, so this is where you shade it. Now this is the pole. Anyway, the conventions you guys have to know right now. You guys have to know. Now this is pole P. Then let's say this is the center of curvature C. Half of it is the focal length, correct? So this is the principal focus. Now again, what we have is from A, we have different rays of light coming. So this is one. Now a parallel beam of light will pass through the focal length, correct? So this is one ray of light. Now another beam of light you guys have to take is from A to this particular point P. Okay, now from A to point P. Okay, so from here to here. So this is one ray, and then from P, what happens is this will reflect in the same angle. So meaning, just a minute. So this is point P. So let me just take it to point P. Now from here, this moves. So this is how it moves, right? So this will be the line. Now if you look at this here, now the image will be formed here, correct? So like this, and this will be an inverted image. So let me write this in a different color so that it's easy for you to get to know. So this will be the image. Now we have this is A dash, this is B dash. Okay, now clear with what is happening in the figure? So we have AB. From AB is the object. From A, two rays of light are moving. So one is this and the other one is moving like this. So both of them will meet at some point here. So that will be A dash B dash. Okay, now let's call this point as, let's say, E. Now from E, again we have to drop a perpendicular. So from E, so we are trying to drop a perpendicular onto the principal axis. So let's call that point as N. So I'll just explain what the figure is. So you have a concave mirror and then you have an object AB. Now from object AB, we have different rays of light coming. So one is AE, which is parallel to the principal axis and it is passing through the principal focus. Then AP, which is passing through the pole of the mirror. So both the rays will come and converge at this point, which is having A dash B dash as the image. Now what we have E to N. So we have EN is perpendicular to PB. Now here PB is nothing but the principal axis. Okay, now what we have, see, take A dash B dash F, A dash B dash F and ENF. So triangle A dash B dash F and triangle ENF. Now these two triangles are similar because angle A dash B dash F, this one, and angle ENF, these two are equal to 90 degree. and you have a dash f b dash is equal to, now when you talk about a dash f b dash, we have e f n, these two are equal because they are vertically opposite angles. So if two angles are equal, then obviously the two triangles are similar, correct? So we have triangle a dash b dash f similar to triangle ENF. Since these two are similar, then sides will be proportional, correct? So what we have, so we have a dash b dash by En. So a dash b dash divided by En is equal to b dash f divided by Fn. B dash f divided by Fn. Okay. Now what we have, see, Pn is very close, correct? So what we can write Nf is almost the same as Pf. So we have Nf is almost the same as Pf. Now what will happen to this above equation then? So we have a dash b dash divided by En is equal to b dash f divided by Pf. Alright, so we have this to be one of the equations. Okay, now what did we, remember the sign conventions and all the properties and the formulas and all the rules you have to follow? Every distance has to be measured from the pole, correct? So b dash f can also be written as pb dash minus pf, correct? So what we have is, we have b dash f is equal to pb dash minus pf. That also we can substitute here, correct? So what we get is a dash b dash divided by En is equal to pb dash minus pf divided by pf. Okay, now if you look at this triangle again, now if these two triangles are similar, it's okay. Now AB and EN, don't you think they are the same? Because we are talking about a rectangle, correct? So what we have AB is equal to En, correct? So we have AB is equal to En. So substitute that. So we have a dash b dash divided by AB is equal to pb dash minus pf divided by pf, right? Okay, now hold on to this equation. Let's call this as equation number 1. Okay, now what we are doing is we're considering triangle ABP and a dash b dash p. So again I'll repeat, we are talking about triangle ABP and triangle a dash b dash p. Now these two triangles are also similar, right? Because the angles, you have angle ABP is equal to a dash b dash p is equal to 90 degree, and angle APB is equal to a dash pb dash. Since these two angles are same, so we have triangle ABP similar to triangle a dash b dash p. We have AB by a dash b dash is equal to BP by b dash p, correct? Okay, now the same, so in this equation you can also write a dash b dash by AB is equal to pb dash divided by pb, correct? So call this as equation number 2. Now look at LHS of equation number 1 and LHS of equation number 2. Both are the same. So that means you can equate the RHS, correct? So what we get is PB dash minus PF divided by PF is equal to PB dash divided by PB. Now this is the equation what you got. Now we have to consider the sign. So the Cartesian sign conventions you have to take. Right. Now according to Cartesian sign conventions, what we have is PB dash will be minus V because you are going against the direction of light. So we have minus V minus of minus F because focal length is also negative, divided by minus F is equal to, now PB dash again minus V divided by minus U, right? So these two negative signs will get cancelled. Now you have F minus V by minus F is equal to V divided by U, right? Now if you cross multiply, so you have UF minus UV is equal to minus VF, correct? Now divide the whole equation by UVF. Alright, so we get 1 by V minus 1 by F is equal to minus 1 by U, right? So since you have this, what we'll do is you have to rearrange this. So if you rearrange, you will get 1 by F is equal to 1 by U plus 1 by V. Now this is what we call as mirror formula. So mirror formula is 1 by F is equal to 1 by U plus 1 by V. Now go through the same video again and understand how to do the derivation, which triangles you have to take and what sign conventions you have to take.